Hello everyone and welcome back. So this time we'll be talking about conversions. We're going to do a few examples of this. I'm not made just converting the same temperature to several different scales. And we're also going to figure out how you can do that. Like here are the equations. Here's 4 different equations, 2 for Fahrenheit to Celsius. This gave you both ways. I gave you the equation that tells you how to get to Rankine and the equation that tells you how to get to Kelvin. Now remember that Rankine and Kelvin, they start at 0. They can't go negative. There is no negative Rankine, there is no negative Kelvin. So if I convert from Fahrenheit to Rankine, the number always gets bigger because Rankine has to be more. It's the same temperature, just on 2 different scales, but the numerical value will be more for Rankine. Same thing for Celsius to Kelvin, it gets bigger because Kelvin is starting at 0 while Celsius starts at where water freezes, and there's obviously temperatures that are colder than that. So these aren't things you have to necessarily memorize. They're in your book, they're in your notes, hopefully. They're in this PowerPoint and you can print it off. But, use it to your advantage. Remember this. So let's try a few of these out. Let's say I want to take 30 degrees Fahrenheit to Celsius. Well, I have this equation right here. So I plug in and I put 30 degrees right here. And when you're doing these equations, not conversions, just equations, all these 4 are equations, they're not conversions. When you're doing equations, you have to make sure you're careful to just get rid of your units until the end of the equation. Just forget that there's any units at all, and then do everything, and then add the unit on at the end. Because it's an equation, it's not meant to be taken for variables. That's why I do like the T and in brackets degrees Fahrenheit is saying, what is the temperature in Fahrenheit, but just give me that number. So I plug this in, it's not too terrible math, and I get a negative 0.11 degrees Celsius. It works. So you can see that 30 degrees Fahrenheit, that's really close to 32 degrees Fahrenheit, which is where freezing is. And water freezes at 0 degrees Celsius, so this makes sense. 30 is slightly below freezing, and so our value is slightly below freezing for Celsius as well. Okay, 30 degrees Fahrenheit to Rankine, it's really simple. We just add 460 and we're done. So 30 plus 460, 409 degrees for Rankine. So you can see there's a big difference in numerical value, but the temperature is the same. It's the same temperature, just 2 different scales. Okay, 30 degrees Fahrenheit to Kelvin. There's lots of ways you can do this. In my opinion, it's easier to go to Rankine, like you jump from Fahrenheit to Rankine and then Rankine to Kelvin. That's my preference always. But I didn't do that this way because, you try that on your own. Just as a little spoiler, if I had done this, actually I already showed this to you later on, but it's not hard to do. So first off, we're going to get Fahrenheit to Kelvin. We got to switch scales. So we're in the relative scale, so we're going to jump over to Celsius, and then we're going to jump over to the absolute scale. So first for Celsius, we have that equation. We just plug in our number and we get 0.11 degrees Celsius. We already solved that, so you knew that. And then go from Celsius to Kelvin, it's very simple. I just add 273. You see me doing that right there. It's always 273. And in doing this, you get 272.89 Kelvin. Now, that's done. You've gotten Kelvin. You're good. It takes 2 steps. It will always be 2 steps unless you write down a new equation to go straight from Fahrenheit to Kelvin. And you can do that if you want to. I've had some students who did that in the past where they write an equation for everything. Have a big equation sheet so that they can just look at it and say, well, I don't have to worry about all the steps. This goes straight from Fahrenheit all the way over there, and I'm done. But as I was saying, there's kind of an easier way, which is what I would normally do, which is go to Rankine first, and then to get to Rankine to Kelvin, just divide by 1.8, because they're both in the absolute scale, and they're on an absolute scale, so we can use a conversion factor. Makes things a lot easier in my opinion, but that's up to you. There is a slight difference because it's not actually 273, it's like 273.15. It's not 460, it's like 459.8 or something. There's some decimals in there that your book rounds, and it's more or less accurate. So I hope this helped you, and I'll see all of you next time. Bye-bye.